Welcome to the third topic of the Advanced Higher Maths course, which is partial fractions. So before looking specifically at the subtopic, let's look at just in general what we mean when we're talking about partial fractions. So what we mean basically is doing the reverse process of adding two separate fractions to put them into one fraction. So for example, you'll know how to do 3 over x plus 1 minus 1 over x plus 2. You'll know that you'll be able to do to multiply these, so you have a common denominator, then you can perform the subtraction, and you'll get 2x plus 5 divided by x squared plus 3x plus 2. So that's fine. But now a slightly trickier process is to do this the other way around. So if you start with the whole fraction here, and you need to split it into separate fractions. And so we can broadly split this into 3 cases, which are to do with how the denominator factorizes. So it could be either distinct linear factors, irreducible quadratic factors, and repeated linear factors. Now once you've learned how to do distinct linear factors, which are the first type, although it's the easiest, in some ways it's the hardest because it's the first one you're doing, and once you've done it, it'll be easy to do the next ones. You'll understand how to learn the new techniques, and so the tricky part will be understanding what we mean by partial fractions and just sort of how we format it. So I'm going to I think this is a good topic to put steps on, where you can just have a method that works pretty much every time when you're splitting something into partial fractions. So number 1 is to factorize a denominator, or in fact number 1 is probably to check degree of numerator is greater than the degree of the denominator, because it's a bit more complicated if that's not true. If the degree, in fact, degree of numerator is less than degree of denominator, because otherwise it gets a bit more complicated and there's one more step. So the degree of the numerator needs to be lower than the degree of the denominator for now. Step 2 is to factorize denominator. Step 3 is to figure out which type of denominator, so like distinct linear factors, irreducible quadratic factors, and also ones we're going to see in the next videos. Which type of denominator. Then number 4 is to find an equivalent expression, which we'll see. From this step onward, it's normal if you don't really understand. This is sort of what we're going to see in this video. So equivalent expression. 5 is to put in one fraction, keeping with A's and B's. Once again, that's completely normal. In fact, you shouldn't understand what this is. Completely normal. It's just so we can write down all the steps and we can come back to it when we're actually solving a problem. Then plug values of x to solve. Then 7, put back into original expression. Now, maybe I've missed some things, but that's fine. We can add to the list afterwards. So let's just look at this with a practice problem. So these are the steps that you shouldn't understand, right? That's normal if you don't understand these steps. So that's what we're going to be looking at. Now, by equivalent expression, what I mean is that each type of denominator has a sort of equivalence. So the best way is probably to just show it. So we had x plus 16 divided by x minus 2, x plus 4. So this is distinct linear factors because the factors in the denominator are different and they're linear, which means their degree is 1, right? So they're distinct linear factors. If they weren't distinct, this would maybe be squared, so we have the same one repeated. And if they were irreducible quadratic factors, there would be something squared. So this is equivalent to a, so something we don't know what a is, over the first linear factor. In fact, it doesn't matter the order, of course, plus b over the other one. And if you had more, it would be plus c over the next one, etc. But some fraction with two linear factors in the denominator is equal to a over the first one plus b over the second one. Now that's sort of, so it's already factorized for us, the degree is lower, that's fine. Which type of denominator? So it's distinct linear factors. Then we can choose our equivalent expression, which in this case is this. Now we need to put it into one fraction, so this needs to be put into one fraction with containing a's and b's. So you can actually just put this into one fraction as you would anything else, as you would something like this, right? So this is ax plus 4 plus b x minus 2 divided by x minus 2 x plus 4. But you'll see now, so if we ignore the middle one, right, this here is equal to this. And so what we can do is we can see the denominators are the same, so we can cancel them out. So x plus 16 is equal to ax plus 4 plus b x minus 2. So there. And so now we've actually done step 5, right? We've put it into one fraction, and I should put and cancel denominators. So in fact, as we go further on, I'll probably skip this step because it's a bit long sometimes to write out, and you'll start understanding that you can just sort of multiply this one by this one by this one, and get rid of all the denominators. But we'll go for all the steps for now, definitely, so you understand where things are coming from. Now, it says plug values of x to solve. So what do we mean by that? Now, I find partial fractions, a way of solving for a and b, quite interesting, because I'm pretty sure, like, no other area of maths really allows you to just do this. What we can do to solve it is actually just plug in the value of x, right? So we can plug in certain values of x, and that's allowed, we're allowed to do that. But there are specific values we want to plug in, because here we have two unknowns and one equation, so we want to get rid of one of the unknowns. And to do this, well, we're going to plug in a value that makes one of the factors 0, because then, let's use x equals 2, then this disappears, right, because 2 minus 2 is 0, so the whole b term disappears. So 2 plus 16 is 18, because x is equal to 2, and x plus 4, so 2 plus 4 is 6, so that's equal to 6a, and the b term disappears because 2 minus 2 is 0 times b is 0. And so this means that a is equal to 18 divided by 6, which is 3. So now we've solved for a. Now we need to solve for b, which we're going to do by plugging x equals -4, because that's going to rid us of the a term. So minus 4 plus 16 is 12, the a term disappears, and that's equal to -6b, which means that b is equal to, so 12 divided by -6 is -2. And so we've solved for a and b, so that's fine. And now we need to complete the last step, which is to put it back into the original expression. So we know that a over x minus 2 plus b over x plus 4 is equal to our original expression. Now all we need to do is put our value for a and b back into here. So to conclude, x plus 16 divided by x minus 2 x plus 4 is equal to 3, which is a, divided by x minus 2 minus 2 divided by x plus 4. So there you go, we've just completed a partial fractions question, and it's completely normal if you still don't understand and if you're still lost. We're going to practice this quite a lot, and so you'll be able to get the hang of it pretty quickly, I hope. So let's look at the second example. Let's look at our original one, but actually go through the whole process to make sure. So that's another thing. A good thing about partial fractions is the fact it's very easy to check that your answer is correct. You can just put it back under one fraction. So 3 times x plus 4 minus 2 times x minus 2. So in fact, we can double check. So this is equal to 3x plus 4 minus 2x minus 2 divided by x minus 2 x plus 4. So the denominator is definitely good. We just need to check the numerator now. The numerator is 3x plus 12 minus 2x plus 4 divided by x minus 2x plus 4. And so we can see 3x minus 2 is just x, 3x minus 2x is just x, and 12 plus 4 is 16, so the numerator is equal. So this is the correct answer, but you don't need to check every time. You should be fairly confident with your answers. So let's look at the original example. 2x plus 5 divided by x squared plus 3x plus 2. Now you can try and have a go by yourself. Technically you should be able to do it, so press button, have a go. Alright, so I'll assume you've tried, otherwise don't worry, once again, we'll go through all the steps. So, first of all, the degree. Alright, that's fine, this is degree 1, this is degree 2, so all good. Now we need to factorize, so this is equal to 2x plus 5 divided by x plus 2, x plus 1. So we've factorized. Now which type of denominator is this? Well, thankfully, because that's the only one we've learned, it's distinct linear factors. And so its equivalent is going to be a over x plus 2 plus b over x plus 1. Alright, and now we just solve. So we're going to go for instead of putting it under one fraction, is equal to a x plus 1 plus b x plus 2 divided by x plus 2 x plus 1. Now the denominators here and here cancel, and so 2x plus 5 is equal to a x plus 1 plus b x plus 2. So now we can just plug in values of x to solve for a and b. So we'll plug in x is equal to negative 2, which is going to get rid of b. So 2 times negative 2 is negative 4 plus 5 is 1. So 1 is equal to, so negative 2 plus 1 is negative 1. So negative 1a, if you prefer. So now this means that a is equal to negative 1. Now if we plug in x is equal to negative 1, we'll solve for b. So this term disappears. Negative 1 plus negative 2 plus 5 is 3, sorry. So 3 is equal to, so negative 1 plus 2 is 1, so that's equal to b. So it's just straight away the answer. And so now we've done this, we've solved, and so we just need to put it back in the original expression. And so this becomes, so negative 1 over x plus 2 plus 3 over x plus 1, which for cleanness we're going to write the other way around, because having a negative up front is not very nice. It's equal to 3 over x plus 1 minus 1 over x plus 2, which is sure enough what we had when we did it the other way around. That's fine. Now we'll look at one last example, which you should be able to do by yourself now. And don't worry if you still can't. When we practice the other types of denominators, it's still going to help you practice this one and help you understand better. So, let's say we have, let's do 1 over 2x squared plus 3x minus 2. I think that factorizes, yep, it should normally. So try and split this into partial fractions. Alright, so I'll assume you've had a go. So the first step is check the degree. Now the degree is definitely lower on the numerator because this is degree 2, this is degree 0. So factorizing, this is equal to 1 divided by 2x plus 2x minus 1 times x plus 2, which is done. I mean, I don't know how you factorize, so I'm just going to factorize. There's about a billion methods out there on how to factorize, so I'll just do it. Now, which type of denominator? It's thankfully distinct linear factors. So the equivalent is going to be a over 2x minus 1 plus b over x plus 2. Alright. And now we need to put it under one fraction, but I'm gonna assume that you can do this fast enough now to understand that we're gonna multiply these and then the denominator is just gonna cancel. So this is actually just gonna come out as 1 is equal to a times the other factor x plus 2 plus b times 2x minus 1. And now we can plug in our values. So we're gonna plug in x is equal to negative 2 to get rid of a. So this gets rid of, this is still 1. So that's going to be negative 5b, because 2 times negative 2 is negative 4, minus 1 is negative 5, which means that b is equal to negative 1 over 5. Now if we plug in x is equal to 1/2, then we get that 1 is equal to, so this disappears because 2 times 1/2 is 1 minus 1 is 0, and 1/2 plus 2 is 5/2, so this is equal to 5 over 2a, which means that a is equal to 2 over 5. Now fractions are fine, right? It's maybe going to be a slightly less clean answer, but it's still completely fine. I was going to say, so now we plug these back in, we get 2 over 5, so that's a over 2x minus 1 plus negative 1 over 5 divided by x plus 2, which simplifies to, so that 5 can go on the denominator, so it's 2 over 5 2x minus 1 minus, because the negative can go in front, 1 divided by 5x plus 2. And so you've just solved, hopefully, your own linear factors problem. And in the next video, we'll be looking at irreducible quadratic factors, so you're able to solve more partial fraction questions.